Hi, I'm going to show you how to do this genetic engineering lab. The first step, it says, is to create a fictional plasmid and to copy the sequence that's on your paper onto a colored sheet of paper. So I've already done that. The next step is to write the complementary letters on the opposite side. So I'm going to put G goes with C, A goes with T. So I'm going to do that right now. And we'll see if you can kind of watch me doing that, and you'll do the same thing. I'm going to put G with C, A with T, T with A, T with A with T, G, T, C, T, T, A, G, A, T, C, T, G, T, A, C, A, G, G, T, C, TACG. So now on my strand I have the original, and then I also have a complementary side. The next step says to tape this into a ring. So to tape it into a ring, I'm going to go like this. Just going to make it into a ring shape, and I put a little piece of tape here and I have a nice ring shape. And then it says get a second strip of paper, and then it says that this is going to be DNA, and this is from a pig. So I wrote out the sequence that it says in number 4. And then again it says to write the complementary base pairs, so I'm going to do that. So we can watch how I do that. So I have G, and I'm going to put G with C, A with T, T, A, G, A, T, G, T, G, G, C, T, A, C, 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 T, T, A, G, C, A, T, C, G, A, T. So now, if you look, you can see I have the original and then I have the complementary pair right below. And then it says the part in bold is the gene we use to mark insulin. So I'm just going to underline that. So it was the TACACCGAT. G. So this section that I have, watch out, Oliver. This section that I highlighted is the part of the DNA right over here. That was bold on your paper, and I just highlighted it. This is the gene to make insulin. So the next step, it says, is to define a restriction enzyme. A restriction enzyme is going to cut the DNA at a specific spot. So in this lab, there's a restriction enzyme, EcoRI, and it always cuts the DNA at AATT. So it says if you see that, to make a zigzag. So I'm going to show you how that looks. So I'm going to find the AATT. I'm going to make a zigzag, and then I'm going to find the AATT on the other side, and I'm going to make a zigzag. So right here I made a zigzag, and then I made a zigzag on the other side. And then the next side, it says use the same restriction enzyme to cleave the plasmid. So I'm going to take my ring that I have right here, and I'm going to find where I have an AATT. So I have an AATT, and I'm going to cut this open like this. So I made a zigzag like this. So the next step is I'm going to cut open my ring right where it says the AATT. This is what a restriction enzyme does, is it cuts right here. And then I'm going to cut, so that's the plasmid, and then right here I'm going to cut the same sequence for the pig DNA, because I'm trying to get the pig DNA into the bacteria DNA. And I cut this AATT. So now, if you see, I've cut this, And then I have this. And now we're going to put this together like a puzzle piece. It doesn't fit totally perfect, but close enough. And I'm going to tape this. So I'm going to match up the AAs and the TTs. And then I'm going to turn it into a circle. And hopefully if you did it right, the AA and the TT are going to match up. We have a little singer right here. And now I have a plasmid. The pink is from a DNA, from a bacteria. And then the yellow is from a pig. So now this is a recombinant DNA because it's DNA from a bacteria and then DNA from a pig. And we can use this in bacteria to make hundreds of copies of this insulin. So bacteria replicate like crazy. So I can use this to make lots of copies of this. Sorry about my singer in the background.